Hello to all of you. This is Dr. Dhaval Maheta, and today's discussion topic is text analysis in R. It is estimated that around 80% of the data which is generated in the world is unstructured data. Unstructured, it means it does not have a fixed schema. If I talk about structured data, it is having a fixed rows and column, but in case of unstructured, this schema is missing, and therefore we name it as unstructured data. The best example of the unstructured data is the text file. Where the text analysis is used these days is used for monitoring online social platforms for security purpose. A lot of text data is generated on Twitter, Instagram, LinkedIn, and Facebook, and the companies want to get the information about their product and what are the changes which they can do on their existing product to make their product better. Text mining is effectively used for customer relationship management also to address the issues of the customers. We can also rate the movies, or we can have the review of the movies by using the sentiment analysis, which requires a good knowledge of text analysis. What are the packages which are required? They are TM, then Plier, ggplot2, wordcloud, rcolor snowballc. Once we have collected the text file or the unstructured data, we will have to create the corpus. Basically, it's a main structure in TM package for managing the documents. There are two types of corpus. One is VCorpus and there is a PCorpus. VCorpus is a volatile corpus which gets destroyed automatically when our object is closed. On the other hand, PCorpus is a permanent corpus. There are some operations which we'll have to carry out once we have loaded the document which can be a text file. And for this we will have to first install the package that is TM, and in this TM, the full form TM is text mining, and there are many functions in this TM which can do some operations. I have collected the speech of last 5 years of our honorable prime minister, and I made one folder speeches in C drive, and these are the 5 speeches which I have considered. Now I will go in R script. First of all, I will load the library RTM, then NLP, that is natural languages processing. Then I will say cname file.path c: speeches, and it will directly get connected to the speeches, that is a doc file. If you want to see in what format the file is, see the format is text format. Fine. Let us go back on the R script. Now we will have to create the VCorpus as we have already discussed. So cname and then docs VCorpus directory source cname. So all the documents now are in the corpus. Now we will have to carry out some operations. These operations can only be done if you have loaded the TM package. Let me change this. Right. So the first operations which we are carrying out on this documents is docs TM map docs remove punctuation. By running this command, we will be removing the punctuations and other special commands which are there. So run. Now I'll run the command remove the numbers. Now in case of text mining, our objective is not to count how many times a particular number is repeated. So we have to remove these numbers from corpus. So I'll run this. The next thing which I want to do on this document is I want to convert all the words into lowercase. Basically, our software is very case sensitive, and and you can say anything which is written in uppercase is not equal to the lowercase. So for the sake of simplicity, all the words are converted into lowercase. Okay, so let us run this command. Now there are some stop words in English which we want to remove from our document. See these words: able, about, after. There is no point in analyzing these stop words, and therefore it is necessary that we remove this from our document. How we can do? We'll again go back and we'll now run remove So TM map docs remove words, stop words which are in English. Run. Now there are some special words which also you can remove. Here, considering the speaker, brothers and sisters are repeated quite number of times, and these are some special words which I want to remove. And therefore, I will run documents tm map docs remove words c brothers and sisters, and that also will be removed. Now in English language, there is a concept of stemming and lemmatization, removing common words ending. So in any document, there are some words which have a common words ending such as ing, es, and s. Say for example, pray, prayer, and pray. This is referred to as stemming the document. The frequency of the words have common root. That is, say for example, if I talk about pray, prayer, and praying, we want a common root. So stemming is the transformation in which all the documents are reduced to their common root so that appropriate frequency of the words can be computed. So pray, prayer, and praying will be reduced to pray. Now we'll require a library for this, and the library is snowballc. You can very well install the packages from here. That is snowballc. Once this is done, snowballc, you install it and then activate the library. The command line will be docs tm map docs stem the document. Now there is also a concept of lemmatization. So it's a process of grouping together the different inflected forms of a word so that they can be analyzed as a single item. The word gentle has soft as its lemma. So the stemmer is, see, basically the stemmer is not in the position to recognize a dictionary lookup for both these words. But the lemmatization has, you can say, has the power that the word pray is the base form for the word praying. Both these words are meshed in lemmatization and stemming. So stemming will only reduce the word, but lemmatization will go for the dictionary meaning and it will try to club the word in one root. So that is lemmatization. Now, after doing all this analysis, it may happen that there are many words which we have deleted, many numbers which we have deleted, many punctuation marks we have deleted, and therefore there may be some white space which is left out in the document, and therefore we want to strip that white space. So documents tm map document strip white space. Now I want to convert this entire documents into plain text document. So after conducting the above operations on corpus, our objective is now to convert the unstructured data into the structured data. So for this purpose, we'll be using the document term matrix, this one. The frequency of the words in this corpus are generated in a matrix structure known as document term matrix. In document term matrix, the term words are represented by the columns and the documents are in rows. The matrix entry, if a word appears in a particular Word document, corresponding to the row and column is 1, else it's 0. If a word occurs twice in a document, it is recorded as 2 in the matrix entry. Let us see how we can do this. So DTM, document term matrix, docs, run. Then I'll simply run DTM. So I'll get the sparsity and maximum term length and term frequency. And how many, you can say, non-sparse entries are there. Now, basically, sparsity addresses the issue of there are many terms in the document which may be repeated only once, and we want to handle those terms which are not frequently repeated, and therefore it is giving me that sparsity in the document is 79%. Now you can remove this sparsity only when you convert this DTM into the term document matrix. So what's the whole concept? There are some words which have a very less frequency of occurrence in the document, and we want to remove these words from our document. So we'll convert this first into TDM. TDM is term document matrix, and docs. I'll run this. I'll get TDM. So when I will run frequency column sums as dot matrix TDM, I'll get 6325. That's the frequency of words which are there. Now, how to handle this sparse terms in our document? Let's see. We will have to give the command dtms remove sparse terms dtm 0.1 10% and dtms, and you can see now the sparsity is 100%. I can also generate the frequency, that is column sums as dot matrix dtms run frequency. Now when I go on changing the sparsity, let's see what happens. Now I have made the sparsity 0.15, and you can see when I'll run this remove sparse terms dtm 0.15 run frequency. So now these words which have been generated, they are on the basis of sparsity which has been removed as 15%. Now let us increase this to 20 and see what the result we will get. Run, 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 and run. So we will get a different result. Okay. Again, if I increase this to 30%, what will happen? Run, run, run. So just see. So how much we want to keep the sparsity, it wholly depends on the researcher. Now we want to order it on the basis of the frequency, that how frequently they are occurring in the document. So we want to organize in ascending order. So order frequency, run. So now I'll say frequency head ordinal order, and I'll get the words on the basis of how they are increasing. Now I'm passing the command, that is add frequency 40. Give me the list of first 14 words. So head frequency 40, and you will get ABL, accord, account, achieve. Find frequency terms DTM, low frequency 32. If I run this command, see what I get. Now these are the words which are repeated in the document 32 times. You can also see that there are some words like can, like, and you feel that these words don't have any, you can say, relevance in our research, and therefore you want to drop these words. So what you will do, it's basically a very iterative process. You will go in the remove words, and you will insert those words which you want to remove it by saying comma can, and then you will repeat the procedure again. Fine. Now I want to have a list of words which are repeated at least 50 times in the document. So I will again write down the find frequent terms DTM, DTMS, low frequency, and you can see these are the words which are repeated 50 times in the document. Now I want to carry out the association, that this freedom word is associated with which other word in the document, and the correlation which I'm interested is 0.90. So find associations DTMS freedom core limit 0.90. So you can see in the document there may be an instances that where their freedom will be occurring with the word work 98.9. So high correlation is there, time 0.97, spot 0.90. So it means that a correlation limit of 0.9 which we have specified, it will return the terms that have search term co-occurrence of at least 90%. It will find those terms. Let me again organize, zoom in. Now let me see that what is the association of the word poor with other words in the document. You can see poor, just, strength, So these are the words which are co-occurring with the word poor. Now TDM, which we have already, it's a transpose of document term matrix. We have already generated it. TDM is equal to term document matrix docs. Now we'll be running this thing here. So m as dot matrix TDM run will be sorting the sort row sums m decreasing true. We'll be creating the data frame on the basis of this v. So d data dot frame words is equal to names v frequency v. Now I'll generate the first 10 words, and you can see on the basis of the frequency, these are the words which are repeated: country, India, govern, will, people, one, today, can, nation, year. I can convert this thing into the bar plot. What's a command line which I'll be using? Bar plot, round bracket d 1 is to 10, comma, space, dollar frequency, alias is equal to 2, and then names dot argument is equal to d 1 is to 10, comma, space, dollar, word, color I want light blue. Main title of the document should be most frequent words, and the while label should be most word frequencies. When I'll run it, I'll get the most frequent words which are there in the document. I can repeat this command with some change in color also if I want. Say for example, if I want this document to be print in red, then I'll do it red. And alias is what? Alias is referring to this. So if I change this and if I make it 1, it will become clumsy, and therefore I am using alias is equal to 2. That's the only reason I'm using alias is equal to 2. Now the same thing, if I want to represent it in another format, then I will be using the word cloud. So first of all, install the library wordcloud, run. Then there is a library which is rcolor brewer. Please install it. Now I'll give the command wordcloud names frequency, minimum frequency. At least the words should be there in the document for 25 times. And you can see on your right hand side, you got the word cloud. At present, don't run this command. I'll explain the importance of this command later on. First of all, let's see this. Now word cloud names frequency, maximum words. Now I want those words which are repeated at least 100 times in the document. So you can see now these are the words. The same thing I can repeat with some more arguments in the command line. Word cloud names frequency, minimum frequency 20, scale 5, point is to 1, color brewer dot pal 6, dark 2, and I'll get the color. Now I can use dark 2 brewer dot pal 6, dark 2 again, and I can run this word cloud with this format also. Rotation, I can change this 0.3 and you can see what happens. I can give the rotation 0.3, 0.4. Okay, now there is a library qdap. Recently, they have came out with a new package that is qdap. You just write down dd frequent terms documents and then run dd, and it will give you all those words which are repeated quite often. Now you will use this dd in the advanced package library, which is wordcloud 2. So first of all, activate wordcloud 2. There is a difference between wordcloud and wordcloud 2. Activate this library. Wordcloud dd size 0.5. On right hand side, you can see the same thing is having a different orientation. Now I will include some more arguments in my command line. dd size 0.5, color, wrap length C, green, blue, and row DD. Again, word cloud DD, size 0.4, color, random light, background. I can also specify background color black. Word cloud DD, size 0.2, and I can also specify that I want the things to be in stars shaped. I can give the rotation also. Minimum rotation pi by 6, maximum rotation pi by 6. Now I want to carry out the hierarchical clustering on this document. Basically, it's an application of cluster. The application of cluster analysis is to text documents into a text clustering. To understand and categorize unstructured textual data, machine learning, and natural language processing, we are using text clustering. The methods we are using is a hierarchical cluster. So first of all, we will remove the sparse terms from the document. DTMSS, remove sparse terms, same thing, which we have already discussed. I'll run the document again. I'll load the library cluster. Now I'll give the command d distance t dtmss. T is basically the transpose which we are using. Method is Euclidean. Run. Now I'll be fitting h plus d is equal to d method word method for clustering will be used. Plot fit hang is equal to -1. Let us see the difference if hang is 1 and hang is minus, or rather when I don't specify hang, what will happen. So I'll say plot fit. And you can see that these dendrograms are not organized properly. So uh, by writing only one command, hang is equal to -1, my things will get much more organized. Now I want to explain all this on k-means clustering. So for clustering words into a specified number of groups, k-means clustering is used in such a way that the sum of squared distance between words and the centroid of the clusters is considered. So first of all, activate the library FPC. Then D distance T transpose of DTMSS method is Euclidean. Run. Kfit K means D comma 2. Then cluster plot S dot matrix D kfit cluster color is equal to 2. Color is true, shade is true, labels is 2, lines is 0. Right. And you can see all those words which are having a high correlation among them or co-occurrence are in one cluster. So there are two clusters which have been formed. Very recently, they have launched the package which is rainette. Let's see the application of this rainette. So library rainette run and activate the quantity also. Corpus split the segments, split underscore segments, documents, segment size is 40, run. Create the tokens by TOK tokens. This is all related to natural language processing. Tokens, corpus, remove the punctuations, true. Remove the stop words. So the same thing now we are trying to do with the different library. ETM, convert everything to the lowercase. Now trim, that is white space, minimum document frequency is 10, run. And then I'll run res rainette DTM, k is equal to 6, minimum segment size is 15. What k is equal to 6? When we will get the plot on this side, I'll explain what k is equal to 6 is. Run. On right hand sides, you can see that we have got 1, 2, 3, 4, 5, 6. So 6 cluster solution I have got. So here, if I change this to 5, let's see what happens. Just a minute. Now I'll get the 5 cluster solution. Now this is basically developed on Rsign. If I go on changing the things here, it's very dynamic. Number of terms to display 24, 25. Number of clusters also I can change from here 4. statistics, on what basis it is generated. So I can say on the frequency terms. So I'll get 5 cluster solutions. Basically, this is a rainette package. We can also do the double clustering here. So for this, what I'll do, res1, same command, rainette dtm, k is equal to 5, minimum segment size is 10. This is res1, res1, and I'll also generate res2. Run, and I'll say my rainette is rainette2 underscore explore res dtm corpus. So you'll have to run all these commands simultaneously. 1, 2, 3, 4. So it can also do the double clustering. So this is all about doing the text analysis in R. All these commands are available in my book, which is available on amazon.in and also on amazon.com. I'll show you the link. So all these codes are very readily available in my book. This book, where I would discuss all these codes. You can follow me on LinkedIn and Twitter. For more videos on data science, machine learning, and artificial intelligence, kindly subscribe to my channel.